Well, that took 5 minutes.
Can you all see my slides?
Yes.
Cool. All right, so it looks like everybody's able to find the Zoom link. So I think I said it earlier, but mistakes are gonna happen. Just right there, I thought I had saved the Zoom link to the lesson and I guess it didn't save. So yeah, thank you all for finding that and pay attention on Slack. So yeah, things are definitely gonna come up, but we appreciate your patience and your flexibility as always. Cool. Let's go ahead and jump right in it. So I'm going to talk a little bit about how the web works, and we're going to get into the HTTP request response cycle. Okay, so I want to talk to you about the internet. How does the internet work? Internet is very, very complicated. A lot of times when you talk about the internet, we'll talk about it in terms of layers. So if you hear someone say like the application layer, the data link layer, there's what they're referring to is like you can think of the internet as like this specific, as 7 different layers on top of each other. And when we talk about one, we're just going to zoom into one specific layer. So for our purposes, we're kind of like working at the top level of the internet layer, what is called the application layer. But I think it's still important to have like just a very brief overview of how the entire thing works front to back. So the internet, you can essentially think of the internet as a network of devices. So if I took my computer and took Danny's computer and connected them together with a wire and had them send messages to each other, that is like a very, very small version of what the internet is. The internet is essentially that, but on a global scale, where we can connect devices from all over the world. I can connect to a device in China, that device might connect to another device in Australia. There's all of these like physical computers talking to each other. So that's what the internet is at its core. These devices have to be physically connected. So I think that's one thing that can get kind of lost in the shuffle when we're talking about the internet, but these things have to be connected physically somehow. Now they can be wireless. So a wireless connection is still a physical connection. So for example, you could have a router. You're probably on your home or your home's Wi-Fi, a coffee shop Wi-Fi. You're probably connected wirelessly to some network right now. So even though it's wireless, the radio waves that it's sending still a physical connection. There's also wires. So there are physical wires connecting devices together. So this is what a fiber optic cable might do. It might connect something from the US to something in Europe. And in fact, I want you to take a look at this map here. So this map is the fiber optic cable map across the entire Earth. So what you can see is if you look in between you know, the East Coast here on this right-hand portion of the United States, we can see all of these like physical cables connecting us to, there's all these that go across to Europe, there's some that go down to South America, and then from South America, we jump over to Africa. And so the world is actually connected by these physical wires. So if you think of like the internet, I want you to like kind of have this picture in your head of like, there's actual just connected devices talking to each other. So these devices are connected, they can exchange information. So they're not just connected blindly. They're not just like sending pictures. They're not just sending pictures. There's just this very rich exchange of information. And when these two devices are exchanging information, what's going to happen is one device is going to be the initiator there. They're going to request one device for some information. Another device is going to respond with information. I have my computer. I want to see a cat video on my computer. So I ask YouTube to give me some cat videos. YouTube gives me back cat videos. The asker of the information is the client. So the asker or the requester, I would also say the initiator here, they initiate this process. And the server is the responder. They're the ones that receive the ask and they respond to it. So the basis of the internet, we have devices connected. One device wants to get some information from another device. So one device acts as the client. They ask the server for some information, the server responds. And there we go. A client asks a server for information, a server responds. So far we have the internet, we have clients, we have servers. Now these clients and servers can't just like send any generic message to somebody. Like you can't just like write an English letter and say like, I want this information. Because we're dealing with devices, these devices need to be able to understand each other. So they need to write in a common language. That common language is HTTP. So HTTP is rules for clients and server interaction. The HTTP rules might say, well, the client needs to specify this information for the server to be able to understand what they want. So by adhering to these rules, we can ensure that clients and servers can understand each other. So there's two types of HTTP. There's two main parts to HTTP. The first part is what the client does. Well, remember, a client is asking for information, so they're going to send an HTTP request, and a server is going to send an HTTP response. So taking a step back here for some of our vocab so far, And mod 2, I kind of mentioned it earlier, we have a ton of information that we have to get through. Vocab is going to be huge here. So we've got HTTP, so far we've got HTTP, client, server, HTTP request, HTTP response. I'm going to jump into an analogy here. So let's jump over to this diagram here. And I want you to think about how the postal system works. So can you all see my diagram here? I switched applications. Okay, that switched over. Okay, so imagine you want to get something from a pen pal that you have. You want to write them a letter. You want to ask them for some sort of information. So what do? So you're standing over here. The first thing that you're going to do is you're going to write and you're going to mail this letter. So you're going to take this letter, you're going to drop it in the mailbox. The postal system is then going to deliver this message to your pen pal. Your pen pal is going to read that letter and they're going to read what you want and they're going to respond in some way. So they're going to mail this response. The postal system then similarly delivers the response back to you and you read it. So that is an exchange of information between you and your pen pal. I want to take some of these vocab words that we've talked about so far and just drop them right here. And I want you to take about a minute or two and think about if you were going to translate this analogy to the internet, how would you do that? How would this diagram change? Where would you label some of these vocab words? Does anybody have any questions on what I'm asking you to do? All right, so take a minute to think for yourself. How would you label this diagram with these vocab words? How would this diagram change if we take this over to the internet? Let's talk about the client first. So in my slides, what I talked about the client being is the asker, the initiator. They're the person that initiates this whole back and forth between the client and server. Can I get a volunteer from the crowd? Who in this case is the client? James.
So the client would be you, or I imagine that house, if that was like what the client was using.
Yeah, and that's a good question of like, is it you? Is it the house? Let's hold off on that like nuance for now. Let's just say like you over here in your house, you're the client. Okay. Who is the server? Can I get a different volunteer? Priya.
Your pen pal?
Yeah. So if clients and servers are exchanging information in this analogy, you and the pen pal are the client and the server. Okay. What is the HTTP request in this case? Hash.
That would be the mail letter.
Yeah, so the HTTP request is the thing that is, it's signifying like, what does the client want to do? What kind of information are they requesting? So this really contains like, what are they asking for? What about the response? Can I get a volunteer? Grant.
Yeah, the mail response. That's what they're asking for. Shoots them a response.
Yep. What's the internet in this diagram? What do you imagine as the internet? Can I hear from someone I haven't heard from yet? Austin.
That would be the postal system.
Yeah, can you explain that a little more?
In terms of, I'm not really sure what you mean.
That's okay. Does anybody, can I get another volunteer? So like when Austin says the postal system is the internet, can we explain that a little bit more? Let's go to Leah.
I guess I was thinking like the things that actually connect the houses, like the roads, are kind of like the internet.
Yeah, I might even say like this is important for what we don't know what's happening. Let me see if I can do this on the fly. For the postal system, like they might be carrying this by airplane. There might be like there might be a train involved at some point. Like there's probably at some point there's just the mailman who's carrying a bag of mail, right? There's all these steps in this system that ensure that our letter is delivered. But do we really care about it? Like, not really. I don't really care how my letter gets delivered. All I need to know is that I write a letter, my pen pal receives it. So I mentioned like the layers of the internet earlier. That's kind of what I mean when I say like we don't really need to worry about the bottom layers. There's all these things that happen in the internet. There's fiber optic cables. There's routers. There's all this like stuff that happens underneath. We don't really need to concern ourselves too much with that. All we need to know is that the internet connects us to other devices. We don't really need to know how it does that. What about HTTP? So I said earlier that HTTP defines the rules for how clients and servers talk to each other. Does anyone have a guess? What is HTTP in this case? Ryan, what do you think?
Well, it's like the protocol that we all agree to send our mail like messages in. So like the mail letters are kind of like HTTP. We, instead of like sending smoke signals or some other form, we've all agreed that we're going to send our messages in letters. So that's like kind of what HTTP is, I think.
Yeah. So like the format of like, dear blah, 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 here's the body of my message. Then here is like a signature.
Yeah.
Kind of. Yeah, I think that's a really good one. What else in this case could be considered that like the rules for how we talk to each other? Priya?
The language itself, like if I'm writing a letter in my language, Tamil, the person better be able to understand that.
Yeah, exactly. Priya, what would happen if you wrote to them and they didn't speak that language?
They'd probably respond back and be like, write me in the language I want you to write me in, or translate it.
Exactly, right. So we, as humans, we speak common languages. So we speak in those languages, we know that we can understand each other. That's what HTTP is at its core. It's kind of like the language that web applications talk to each other in. And yeah, you're exactly right, Priya. If you like tried to send something that was in a different language, like you didn't send an HTTP request, you sent just like your own made up language, the server would be like, I don't know what you're talking about. Please write to me in a language that I understand. Angela?
Yeah, also any conventions that you might have. So like where we place the return address versus the mailing address, or the stamps that you put on the letter.
Mm-hmm.
The HTTP.
Mm-hmm. Yep. Anything that has to do with like the format that we're communicating in. Yeah. Brett?
I'm just wondering, is HTTP just like standard for America, or like, is there any?
This is worldwide. Yeah.
Worldwide. Yeah. Okay.
Mm-hmm. So I do have another version of this diagram here where we've got this kind of like laid out a little bit more explicitly. So the question came up of like in the pen pal analogy, are you the client? Is the like house the client? So if you think of the client as like the thing that actually sends the message, like it's probably the mailbox, like it's the thing that actually is the entry point into the postal system. That's where the analogy gets a little fuzzy. When we talk about clients in terms of web applications, almost always, we'll talk about some of the nuances later. But for now, I really want you to have this in mind that almost always the client is the web browser. The thing that actually writes the HTTP request is not you, right? You've used web applications before. You've used YouTube, Gmail, Reddit, whatever it is. You've used web applications before. You might not know anything about HTTP, right? So you don't actually, as a user, you don't need to know anything about the HTTP specification. The browser takes care of dealing with HTTP for you. So the browser is the client. The browser creates the HTTP request. The internet is responsible for delivering it to the appropriate server. And how does it know which server to send it to? That we'll talk about that later in the mod as well. The short answer is DNS. So the internet delivers the HTTP request. The server is going to read it. It knows how to read it because it's in that HTTP request format. The server is going to send their response back. The internet's going to deliver it, and the client's going to read it. And the client knows how to interpret it because it is formatted as an HTTP response. Travis.
This is just a kind of a random question, but is there any way whatsoever to request information from a server through the internet without using HTTP or by using something else?
Yeah, absolutely. There are different protocols. It's just that HTTP is the standard. We're really not going to use anything besides HTTP. Now, if you and I decided that we wanted to just make our own server language, we could do that. Like there's no reason that we couldn't just invent our own protocols. It's just that no one else would be able to understand them because it wouldn't be, only you and I would know about that. Any questions about anything we've covered up to this point? Okay. Let's take a 5-minute break. Oh, and we'll come back at 11:33.
Thank you, 11:33.
Can you all hear that banjo play?
No.
I'll have to fix that.
And-
Yeah.
Oh.
Don't worry. I'll get it working. Can you all see the timer countdown right now?
Yes.
What if I do that?
Yes.
What if?
Well, now
cool.
it stopped.
Now it stopped.
Yeah.
Is it back?
Yes.
Okay. Thank you for that little experiment. Let me. I'll get started in just a minute here. I'm going to make sure that I share these slides in this diagram with you. Oh, also, I think I saw someone request access to the intro slides. Do you all not have access to that? No, I think that one should be good.
I have access.
Cool. Yeah, it looks like y'all should have access to that. Cool. I will also drop you my slides. I don't know if I can share this diagram. It doesn't look like it.
Are you using Lucid Chart?
No, I'm using diagrams.net. That's okay. It'll be in the recording. All right, I'm gonna jump back into the slides. All right. So I went over that diagram. So just to wrap up here on the HTTP request response cycle, right now where I would want you to be at is, okay, there's this like HTTP thing. It's the rules for clients and servers. Great. Like, what do I need to know about it? There's a lot to know about HTTP, and we're gonna like kind of break that up into several classes. We're not gonna like just dump it all on you right now. I think for what's really important right now is the vocab words that we talked about of client server, and knowing that in the HTTP request response cycle, there is a request initiated by the client and the server is going to send the response. We will talk more about like what are some details about the HTTP request response later in this week. And I think even as early as tomorrow. So client sending out requests and server sending responses is called the HTTP request response cycle. So in mod 2, we're going to be writing the server side code. So in that diagram of like client and server, we're going to be writing code on the server side. And so it's really important for us to have an understanding of HTTP because our job or our code essentially has one job. It's going to get HTTP requests. It's going to send back responses. Now, there's a lot of different things you can do with receiving a request and sending a response. But with that being said, it's very important for us to have this underlying understanding of what's going on with HTTP because that's what our code is doing under the hood. So we're going to need to know how to interpret these requests and send appropriate responses. A lot of this is abstracted away for us, so that it is entirely possible that you could create a Rails app without knowing, knowing very, very little about HTTP requests and responses. However, this is the kind of concept that's going to be, it's going to translate from one programming language to another, from one web framework to another. So knowing the underlying workings of HTTP and the internet, it's really important for you to for you to jump from like one web framework to another. I think it is very, very unlikely that you're going to work in Ruby and Rails for your entire developer career. Okay, so I think that's mostly it on HTTP request responses for now. I'm going to jump into a couple more like vocab type things that are kind of like, for now, I just need you to know them. So the first thing is parts of a URL. I mentioned it very briefly. We looked at a diagram and we saw like a server. Well, like how do we identify a server? A lot of it has to do with URLs. So if you go to Google Chrome or your other web browser and you type in this into your web browser, you type in a different website, like you type in like youtube.com/whatever, that all gets translated into a URL. A URL has different parts to it. So the first part for this URL, the first part is the protocol. So that is almost always HTTP or HTTPS. We can get into the nuances of HTTPS versus HTTP later in the mod. For now, I just want you to know this first part is going to be the protocol, and it's going to be the : / / as part of that as well. Immediately following the protocol, you're going to get the domain. So that's going to be our taskmanager.herokuapp.com in this point. All your domains are going to end with what's called a top level domain. So .com is an example of that, .org is an example of that. At Turing, we use .io, so backend.turing.io is another one. There's all different types of top level domains, but there's the most common ones are .com, .org. Yeah, so this is your domain right here. Notice that there can be multiple dots, which I might refer to as a subdomain. We're not really going to get into that right now. So like backend.turing.io, taskmanager.herokuapp.com. There could be several of these, but they all come together and make the single domain. After the domain is where we're going to get our first slash that indicates the URI or the path. So immediately following the domain, you're going to have a single slash, and then everything after that is the path. So /task/new is the path in this case. Notice that I've labeled it as URI or path. It is possible that you also have a query string. So the query string is identified by a question mark, and then you're going to have key value pairs. So we have question mark title equals task. And then if you have multiple key value pairs, you're going to have an ampersand, this and symbol here. So in this case, we have a query string with two key value pairs. The two keys are title and task. The two values are new and also task. And then finally, you might have anchor tags. Oops, I actually clicked on the link there. For the query, or sorry, the final thing that you could have is the anchor. So the anchor is going to be denoted by this pound or this ampersand, or not ampersand. The technical term is an octothorpe. I just call it a pound, or you might call it a hashtag. This essentially will take you to a specific part on a page. Yeah, this is not going to work exactly. I think there's a good example if you go to like, if I try to look up like the hash documentation. If I go to the Ruby docs here and I just click on any method, it'll put that in the URL. So you'll see it'll actually put a hash in here and anchor you to that specific part. So if I go back to this URL, if I refresh this page, notice it'll go down to the method I compact portion of that page. So if I scroll down and refresh, it should send me back to method compact. It looks like it's a little bit off on that. Anyway, anchor tags, not super important. What I want you to know is just recognizing that they start with this pound symbol. So these are all parts of the URL. I'd fully expect that you need to like go back and review this. We are going to review it tomorrow as well. For now, the most important one I want to point out is your URI or path. So again, that's the slashes immediately following the domain. URI stands for Uniform Resource Identifier. Kind of circling back to the HTTP request, your HTTP request is going to include that URI or path. That's going to indicate what you're trying to access. So for example, /tasks or /task/5, this is from your task manager app. And the HTTP request is going to include a verb. This is something that you can't see in the URL and it's kind of just hidden, but it is there and it indicates what you're trying to do. So if the URI or the path indicates what you're trying to access, the verb indicates what you're trying to do. Verb is what you do. Some examples of these verbs, the 5 that we are going to be concerned with are a get verb, which indicates we're trying to retrieve something, post, which indicates we're trying to create something, patch or put, which indicates we're trying to update something, delete or destroy, which indicates we're trying, or delete indicates we're trying to destroy something. So I think for this first day, this might feel like a little bit of memorization, but I do want you to know pretty much this slide right here. The HTTP request is going to include our verb or a path. The verb is the slashes after the domain. I'm sorry, I said verb or path, URI or path. And we're going to include a verb. There's 4 main verbs, and this is what they correspond to. Does anyone have any questions right now? I would definitely expect at this point for things to feel like a little bit fuzzy, a little bit like, why do I need to know this? I don't really know how this fits into my code yet. That's totally fine. But with that being said, any questions? Okay. All right, the last thing that I want to do for this morning is do a survey. So I'll show you what the survey looks like before I send it out. So Tim and I are going to try out this idea here for this mod of getting feedback on our classes immediately after the class. So what you might have done in mod 1 is you might get a end of the week Friday survey, and it'll have some questions on like, was anything unclear or foggy? I think every mod does it differently, but some versions of those questions might be like, you know, was this topic unclear or foggy? Do you have any questions from class, et cetera, et cetera? We're going to try and get more feedback on specific classes right after they happen. So that'll make your Friday classes shorter, or your Friday surveys shorter. And it'll make it so that the feedback should be fresh in your mind. The other thing that we wanted to do with this survey is really try and make it short. So there's 3 questions that are just strongly agree to strongly disagree on I was engaged, the learning goals are clear, and the class was an effective use of your time. We also have a question down here that's just kind of like very generic. Any feedback you have, use this space to explain any of your answers. So like maybe you disagree that this was an effective use of your time. Please just explain like, why do you think that? We might have to do some trial and error with the settings here. I have it set right now so that you have to log in with Google to be able to respond to this. So that's going to help us keep accountable just to see everybody's answers coming through. With that being said, this should still be an anonymous survey. So it should just show me if you responded, but it shouldn't show me like which survey corresponds to your name. It should also allow you to go back and edit something. So say like, you know, we only have 2 minutes before lunch and, you know, you just need to like fill this out and then run to lunch. Maybe you want to like just fill out the first 3 questions and then leave some more detailed feedback later. You should be able to go back in and edit your response if you have to. Yeah, does anyone have any questions about this? Travis?
Sorry if I missed this, but where is this found?
So I'm just going to post this in your Slack channel. So I'm going to make a new one for my classes and just drop it in the Slack channel. And so I'll try to end class like at least you know, a couple minutes early so that you can go through and fill this out.
So you'll just drop it in the Slack every day after class?
Yeah, and I'll do that just as soon as we're done with questions. Priya?
Is there any chance that you could also add these to the assignment tracker?
Oh, gotcha. Yeah, I don't see why not. Yeah, we can do that.
Thank you, Brian.
Yeah, we might not have it all ready to go for this week, but we'll at least do it for next week and see how it goes, and maybe we'll check in and see like, is that helpful? Do we want to keep doing that? as with all things, just be flexible. We're gonna like continue to just try and iterate, make things as best as possible. And so, yeah. Let me drop that in your channel so you can go ahead and start filling that out. And yeah, any other questions? Tim, is there anything that you have before we wrap up this morning?
No, nothing for me.
Cool. All right. Yeah. Take a minute just to fill out that survey. We will see you all back at 1 for PD.
Thank you, guys.
Thank you.
Oop, I do have one thing. If you're still on the call,
Go for it, Tim.
the PD link is in the calendar. I don't think it should be a big deal for y'all. Like, I don't think it's going to be a different room, but I just wanted to make sure that you knew that that's where it was.
Thank you, Tim.
Yep.
Thanks.
Thank you.
Have a good lunch,
Yeah.
everybody.